Okay, first, I have to talk about Friday night fights. The lesson has started. You've written down 5.5 exploring ratios, page 264, and I have to talk about Friday night fights in the Kerwin house just for a moment. So I fight my kids on Fridays, and that's today. And last night they were talking about it, saying, yeah, today's the day, it's Friday night fights. It's actually Friday afternoon fights, because I'm too tired to fight after dinner. You know, like meatloaf and potatoes, and you don't want to fight. So it's actually Friday afternoon fights, but Friday afternoon fights isn't sound as good as Friday night fights, does it? Now, when I'm fighting my own kids, it's a 2-to-1 ratio. Okay? It's a 2-to-1 ratio. It's a left, that's 1, 2. Okay? And then that's 2 punches. It's 2 punches to 1 kick. Because when I punch my 5-year-old, he's down. Okay, so it's 1, 2, and I let him fall, and then it's a kick. So it's a 2-to-1 ratio. Is everybody okay with 2-to-1? Yeah. So, following that formula, if I punched 4 times, how many kicks would that be? 2 kicks, right? So it's my 5-year-old's here. It's 1, 2, 1, and my 7-year-old comes running from behind me, and then it's 1, 2, 1 because he's down too. So for every 2 punches, it's 1 kick. Yes, we're okay with the 2-to-1 ratio.
Yeah.
Okay. I should tell you, I don't really punch them and kick them. They punch and kick me. I'm the one that gets beat up. Okay? And remember the wounds I had, the scars? I tickle them. They get tickled. I get beat. I'm not looking forward to it. So if I show up Monday, and we're back. Take a look at page 264 in your textbook. And it says on 264, work with a partner. And I want you to look at 264 with one eye and look at the person next to you and point to them and say, hello, partner. If there's 3 of you, there's 3 of you, and that's fine. So look at 264. Notice on 264, at the bottom, there's a bunch of red counters, blue counters, and yellow counters. And we're going to compare them. Just like I compared the punching and kicking. I compared those 2 numbers. Yes? How many punches did I do for all my kids? 2 punches. And for every 2 punches, how many kicks was that? 1. 1. It was 1. Now here I've got compare the blue counters to the number of yellow counters. Somebody quickly just yell it out. How many blue counters are there?
6.
6. And how many yellow counters are there? 9. 6 to 9. So for every 6 yellow counters, there's 9. Sorry, for every 6 blue counters, there's 9 yellow counters. Make sense?
Yeah.
I can also write it this way. 6 to 9. See that symbol? You most often see it in English, but we're going to use it in ratios and math. 6 to 9. 6 to 9. And that's basically it. So what if there were 12 blue counters? How many? 18. Now hold on. How did you figure that out? If I doubled 6, so what do I have to do to 9? I have to double 9 as well. Okay, awesome. Give yourselves a little pat on the back. That was well done. Okay, look at the top of page 265. Now, at the top of 265, I have very carefully and artistically recreated excuse me, the image on my whiteboard. And you can see all the sports balls here. I have 1, 2, 3, 4, 5, 6, 7, 8 tennis balls, 1, 2, 3, 4, 5 golf balls, and 1, 2, 7 basketballs. And we're going to compare these. Okay? Here's the next bit you should write down. Are you ready? 2-term ratio. You will have to know this. 2-term ratio. How many terms do you suppose are in a 2-term ratio? 2. Awesome. This 2-term ratio we're going to compare a part to a whole. Write this down. part to whole ratio. And in this case, the example from the book, it says 7 basketballs compared to all of them. And how many are there?
20.
There's 20. 7 basketballs to 20 sports balls. So we can write this as 7 to 20. How else can we write it?
7 colon 20.
7 colon. What's it, 6? How do I say this out loud? 7 to 20. So I say it the same way. Yes? Good. 7 to 20. There's also another way that we can write that part to whole ratio. We can write this as a fraction. 7 to 20. Write that down too. We can also write it as a fraction. 7 to 20. And we say it 7 to 20. We can also write a part to whole ratio as a percent. Now, how many people know in their head right now, by a show of hands, how I'm going to turn this into a percent? Yes?
7 divided by 20.
7 divided by 20 would work? Okay. And percent means per 100. Is there a number that I can times 20 by to make it 100?
5.
Yep, I can times the bottom by 5 to make that 100. Times the top by 5 to make that 35. Now, who can tell what that percent is going to be right now? 35. Yeah, 0.35 or 35%. We can put the 0.35 there. 35%. So this ratio of basketballs to all the balls can also be expressed as a percent. Are you down with that? Hey, what if I took my handy dandy calculator and I did 7 divided by 20? What number appears in the calculator?
20.
Mathletes, give it a try. 7.
0.35.
It's a 0.35. It says this number, doesn't it? Right. And then I times it by what to get a percent?
100.
I times it by 100 to get this percent. Most people by grade 8 are figuring out that if your calculator says 0.35, what's that going to be as a percent? 35%. Cool. That's part to whole. I'm erasing this. Part to part ratio. A part to part ratio. This will not be compared to the 20 balls. Okay? It'll be compared to some other part of the whole. 5 golf balls. And we're going to compare it to tennis balls. To, how many tennis balls were there? 8. 8 tennis balls. I can express that this way, 5 to 8. I can also express it this way, 5 to 8. I am not allowed to express it as a fraction. I have to stop right here. Here's why. When we work with fractions, we're talking about fractions of a whole item. I ate half that pizza. I ate half of the whole item. But this isn't compared to a whole item. This is part to a part. So in a part-to-part ratio, we have to stop expressing it here. We can't go on and express it as a fraction or as a percent. This is it. This is our part-to-part ratio. Give me some nods if you're keeping up with this blistering pace. Okay, good. Let's erase that. And write this one down. 3 term ratio. How many terms are there going to be in a 3-term ratio?
3.
3. That's right. 5 golf balls to, I've already forgotten, 8 tennis to 7 basket. And we can write that as 5 to 8 to 7. 5 to 8 to 7 ratio. Very good. And then you gotta stop. You can't write that as a fraction or a percent. You can only do that with that first item that we have. Okay, so here's the example. Let's work through an example here. Class party. Oh, that blue is wonderful. I regret not using it earlier. Class party. 16 boys, 15 girls, and 4 adults. What that means is the one teacher that runs the class and the 3 other teachers who are there for the free food. That ever happened to you? In grade 7? Class party, other teachers show up, they're eating your food. It was my chips. I was always the teacher that went to other classes and, ooh, cupcakes. Awesome. All right, boys and girls. How can I express this? Sorry, did you say something? How can I express this as a ratio?
16 to 15.
16 to 15 or 16 to 15?
Wouldn't it be 16 to 15 to 4?
Boys to girls. Now, actually, this brings up a good question. Am I allowed to write this as 15 to 16? No. I'm not allowed to. If your question says boys to girls, what has to be the first number? Boys has to be the first number. And pay attention, it doesn't say boys to girls to adults. Okay? This is a part to whole or a part to part ratio, this one. It's part to part. That's right. 16 to 15 or 16 to 15. These are the ways we can express it. Boys to girls to adults. What is it going to be? 16 to 15 to 4. 3-part ratio. Good. And let's do this one. Adults to total number at the party. How many adults are there? 4. Now the question doesn't give us the total number, but would it be easy to